In order to convert a polynomial, in this case a quadratic, from general form into standard form to more easily graph that quadratic, we want to employ a method called completing the square. Now recall the perfect square trinomial was some term squared at the start and end of the trinomial, followed by a combination of that of the product of those two, but we're going to double it. If we FOIL this or expand this factored form out, we're going to see that we're going to have ax times b 2 times to get our middle term. Now there are some steps. First we start with a characteristic polynomial but we want a to be 1. To ease the process, we're going to divide everything by a, which makes kind of a mess. We're going to divide the first term, second term, and third term by a. But the reason we want that is we want a to be a 1. We want this to be a 1 because when we square this, it'll just make our math so much easier. After we divide everything by a, we'll take our middle term, the coefficient of our middle term, the b over a, and we're going to divide it by 2. And we're going to save this for a little bit for later on. Then we're going to take that b over 2a, or that middle term, that new middle term divided by 2, we're going to square it. We're going to add and subtract it to our new polynomial, x squared plus or minus the bax. We're going to add that squared term and subtract it. Then we're going to take this portion right here and factor that, leaving the rest to be summed at the end. This is what is going to factor. We're completing the perfect square trinomial by creating this term. We're adding and subtracting the same term to the polynomial, which doesn't change the overall value, but it does give us the opportunity to factor in a unique way for the perfect square trinomial. All right, let's look at the example of 3 examples of how to convert the general form to the standard form using completing the square method. First, x squared minus 2x minus 8. We already have a 1 here as the leading coefficient, so we don't have to divide by that leading coefficient. It's already 1. That's great. I'm going to go ahead and write this into this step. We're going to have x squared minus 2x, and I'm going to leave a space for the plus and the minus. Plus and minus, and then we have the minus 8 at the end. I need those 2 numbers. Where do we get them from? Well, we get it from that second coefficient. We're going to divide this by 2 and then square it. So side work, negative 2 divided by 2 squared that. Negative 2 over 2 is negative 1, squared is positive 1. So we're going to add 1 and subtract 1, which allows us to then factor those first 3 terms into x minus 1 quantity squared, and then negative 1 and negative 8 is negative 9. The b over 2a, we're saving this to put it in as the second term of our binomial that we are squaring. So negative 2, let's see, b over 2a is this negative 2 divided by 2, which is negative 1. This is negative 1 squared. And so that negative 1 is what's going to go into the parentheses. Let's look at the second one. 2x minus 10x minus 1. Let me move the paper up. Let's see, you can still see the above example and the steps. We need to divide by 2. So dividing by 2, each one of the terms, gives us x squared minus 5x. I'm going to leave a blank and a blank. Minus 1 divided by 2 is minus 1/2. We need to fill these in. Well, that requires some side work. We're going to take this negative 5 divided by 2, and we're going to square that. Negative 5 times negative 5 is 25. 2 times 2 is 4. All right, we'll insert that 25/4. We're going to add that and subtract it, which that gives no net change, and we're ready to factor. The -5/2 is just that, -5/2. So we have x minus 5/2, quantity squared, and then we have to add these two fractions. Well, this -1/2 is going to turn into -2/4, so we have a common denominator, so we'll have minus 27/4. Leave it as an improper fraction, we're done. The last example, it starts off with a -3. We need to get rid of that -3. We're going to divide everything by -3 because we want a +1 in this in the place of the leading coefficient. So that gives us a positive x squared. Divide the second term by -3, gives us a positive 8x, and the last term is a -5. But we are going to add and subtract a number to this so that we can complete the square. What number are we going to use? Well, we're going to take the 8, we're going to divide it by 2, and then we're going to square that. 8/2 is 4. 4 squared is 16. So we're going to add 16, we're going to subtract 16. Going right to completing the square, we have x. 8/2 is 4. So x plus 4, quantity squared. And then we have -16 and -15, and -5 is -21. And we have successfully completed the square on each of these. This was our general form. Now we have a standard form.